we are solving quadratic functions using square roots, and we'll know that we want to use the square root when the b value is equal to 0. So in this case, if ax squared plus bx plus c equals y, that's in standard form. If the b value is 0, 0 times x, that term drops out, and then we're just left with ax squared plus c is equal to y. So when we're solving an equation and we have x squared is equal to 9, if we want to solve that, we want to do the inverse operation of the square term, which would be of the square operation, which would be square root. And anytime we take the square root in solving, we have to account for both plus and minus solutions, because we can see here 3 times 3 equals 9, and -3 times -3 also equals 9. So both of those solutions are possibilities. So whenever we solve, we need to account for the positive and the negative solution. So here we have an example. We have the equation y equals 2x squared minus 8. And the first thing that we want to do when we solve a quadratic means that one side of the equation needs to be equal to 0. So we're going to substitute y, and we're going to say, when does this equation equal 0? So the next thing we do is we use GEMDES to get the x squared term alone. So the first thing is we look at, for addition and subtraction, we see here we add 8 to both sides. So then we get 8 equals 2x squared. Still using GEMDES, we're going to multiply both sides by 1/2. So we multiply both sides by 1/2, and we get 4 equals x squared. To get rid of the square term here, we take the square root of both sides. And whenever we solve with the square root, we have to account for both the positive and the negative. And we'll take a look at what the graph looks like. So here we have the graph y equals 2x squared minus 8, and we can see that it is the shape of a parabola. And we were trying to find when y was equal to 0. So right here, there's the y value. If we're going up the y, so 0, 1, 2, going down 0, -1, -2. We want to find when is this graph equal to 0. So right there on the x-axis. And we can see that the graph crosses at -2, and it also crosses at 2. So we have two possible solutions there.